Hi YouTube, this is Brendan with Cusack Prep, and in this video we're going to be discussing how to solve absolute value inequalities. Now, the first absolute value inequality that I have here is the absolute value of x minus 3 is less than or equal to 8. In order to solve this equation, or inequality, we first want to consider this to be an equation. So I'm going to set up the equation, the absolute value of x minus 3 is equal to 8. Now, in order to get rid of the absolute value, we want to set what's inside of the absolute value equal to positive the right-hand side, as well as negative the right-hand side. When we do that, we can then solve for x by adding 3 in both cases. So for this first one, I get x equals 11. And for the second one, I get x is equal to negative 5. Now that we have those numbers, we can go ahead and we can set up a sign chart. On the sign chart, I'm going to put 11. And I'm going to put negative 5. Here's negative 5, and here's 11. Now what we do with the sign chart is we evaluate numbers that are in between negative 5 and 11, as well as values that are below negative 5 and values that are below 11 in the original inequality. So let's say I wanted to evaluate 0. Well, if I plug 0 in for x, 0 minus 3 is negative 3. The absolute value, which is 3. 3 is less than or equal to negative 8, so the inequality holds true for the region in between negative 5 and 11. Below negative 5, I plug in negative 10. Negative 10 minus 3, well, that's negative 13. The absolute value of negative 13 is 13. That's not less than or equal to 8, so it does not hold true in this region. Greater than 11, let's plug in 15. 15 minus 3 is 12, the absolute value which is 12. And that's not less than or equal to 8, so it doesn't hold true in that region. So what we can see is it's the region between negative 5 and 11 where this equation holds true. Now that can be represented on a number line like this, or it may be represented as negative 5 is less than or equal to x is less than or equal to 11. Or we could also represent it using interval notation, where we use brackets, and we say negative 5, comma, 11, which would be the domain. Now, negative 5, 11, we use brackets because it's less than or equal. If it had just been less than or just greater than, we would only use parentheses. So let's take a look at another problem that's similar to this. In this problem, we have a little bit more going on. So we just have to remember that anytime we have an absolute value equation or inequality, we have to bring everything to one side before we can do anything with it. So the first thing I do is I add 4 to both sides. And just like last time, I'm going to start by treating this as an equation. So we end up with 2x plus 7 is equal to 28. To get rid of the absolute value sign, we set it equal to positive 28. And we also set it equal to negative 28. Subtracting 7 from both sides, we get 2x equals 21. And for this one, we would get 2x is equal to negative 35. Dividing both sides by 2, we get x is 10.5, and x is equal to negative 17.5. Now, just like last time, we're going to go ahead and set up a sign chart. So, with that sign chart, we start by drawing a line, just like this. And we're going to pick values that are on either side of the line. So I'm going to put negative 17.5, and I'm going to put 10.5, and I'll pick a value in between them to start. So I'm going to start with 0. If I plug 0 into this equation, I get 2 times 0, 0, plus 7, 7. The absolute value, which is 7, 7 minus 4 is 3. 3 is not greater than or equal to 24, so I put a big old X in this region. Let's say I pick a number greater than 10.5. Let's go with 15. 2 times 15 is 30. 30 plus 7 is 37. The absolute value of which is 37. Minus 4 is going to be 33, which is greater than 24. So we get a big check mark in that region. If I pick a number less than negative 17.5, I can pick negative 20. 2 times negative 20 is negative 40. Plus 7 is negative 33, the absolute value of which is 33. 33 minus 4 is 29, which is greater than or equal to 24, so we get a check mark in this region. So what we can say is that x has to be less than or equal to negative 17.5, or x is greater than or equal to 10.5. If we were to write this in interval notation, we would write negative infinity, comma, negative 17.5, union, 10.5, comma, infinity. And we would want these to be brackets here because it is less than or equal to in both of these cases. So I would want to draw a bracket, not parentheses there, bracket. Okay, and that's how you solve absolute value inequalities. Thank you for watching.